So good evening, everybody. My name is Tim Chan from the Methanol Institute. I would like to welcome the participants for today's webinar. The title of today's webinar is LCA Modeling, Establishing the Business Case for Low Carbon Methanol. Once again, I'm Tim Chan. I'm based in Singapore. I represent the Methanol Institute in Asia and Middle East. Just a quick introduction to MI. MI is the Global Trade Association for the methanol industry. We were established in 1989 in DC. Since then, it's been slightly over 3 decades. We've expanded considerably. We've opened offices in Brussels, Delhi, Singapore, as well as Beijing. And these are some of our members. MI has a tiered membership. It goes all the way from tier 1 to tier 4. At tier 1, you'd find the biggest methanol producers in the world. It trickles down to tier 2, slightly smaller methanol producers, tier 3, distributors, some producers, and tier 4, where it gets really interesting because they have quite a variety of technology providers and technology companies developing all sorts of methanol applications for the utilization of methanol as a fuel, as a hydrogen carrier. And I think that's also going to be somewhat a topic that we'll touch on today when we're talking about greenhouse gas life cycle analysis, because it's going to be crucial in evaluating the carbon intensity or the greenhouse gas intensity of some of these methanol applications, and also assess their proposal that they are able to deliver on lowering the greenhouse gas intensities of different essential economic activities. So just quickly about methanol and why we're discussing this topic today. Methanol has been widely used as a fuel for a while now. It started in the 80s when it was blended with gasoline for conventional road transport mobility. But since then, the applications have expanded. It has moved on to be a fuel in cook stoves and industrial boilers. And these days, we're seeing a lot of traction around methanol's use as a marine fuel. So there are many reasons for the adoption of methanol as a fuel. Firstly, of course, energy security reasons, but beyond that, there was also the possibility for the immediate delivery of emission reductions, specifically for the emissions of SOx, NOx, and particulate matter. So those were some of the reasons for why methanol was adopted in the past. But these days, we're seeing that the driver for methanol's adoption in different applications has slightly changed. And mainly because there is this global trend of decarbonization and methanol's ability to be produced from renewable feedstocks, which I will touch on quickly in the next slide. But this ability to be produced from renewable feedstocks allows it to be a fuel with low greenhouse gas intensity. So it can help some of these applications which are facing pressure to decarbonize find a pathway towards a low carbon or carbon neutral format. So let's move on to the next slide. That's where we'll talk about some of the production pathways as listed on the left side of your screen. As you can see, there are the conventional pathways, which are coal, but predominantly most of the methanol that's produced in the world is produced by natural gas. Some of the two pathways that are gaining a lot of interest these days is methanol being produced from renewable electricity as well as from biomass. Because these pathways have been shown or have been proven to be able to deliver on a very low greenhouse gas intensity for methanol as a chemical product and as a fuel. So we at the Methanol Institute work with the International Renewable Energy Association in producing a report on renewable methanol. It's called Innovation Outlook Renewable Methanol. You could Google it, or if you have any troubles finding it, do feel free to reach out to MI staff and we would be happy to share it with you. But in that report, it goes through all the different production pathways, and there were some very, very optimistic projections that were made by IRENA about how by 2050, there will be 250 million metric tons of e-methanol and 135 million metric tons of biomethanol produced annually around the world. And today's global production capacity only sits around 140 million metric tons. A lot of this increase in demand on the road to 2050 is going to be from the use of methanol as a fuel, and especially when methanol is produced from renewable feedstocks, it will become, or it will be utilized as a low carbon or carbon neutral fuel. And the reason why we're having this webinar today is because how do you ascertain the low greenhouse gas intensity of methanol that's produced from renewable pathways? And beyond ascertaining that, you have to account for it, you have to report it. So all these are some of the issues or the challenges that different industries are facing when they evaluate the use of alternative fuels that includes methanol. So the purpose of today's webinar is to promote the use or the utilization of greenhouse gas life cycle analyses to really understand the kind of emission intensity that you have across the value chain. We believe that it's probably the best way, the most transparent way to really understand the environmental footprint of an organization, as well as some of the energy processes that we're engaged in. So with that, I'm going to conclude my presentation. These are our contact details. If you are able or if you would like to reach out to us regarding any kind of questions about methanol, do feel free to do so. I do believe I did forget to touch a little bit about housekeeping before we start on today's webinar. So I'll go through that quickly. So firstly, audience, you are muted. You will not be able to verbalize your questions. So if I can draw your attention to the control panel on your screen, you should be able to see a questions tab, and that's where you should go to type in your questions. We will receive them. There will be a Q&A session at the end of the webinar. We will try to address as many questions as possible. On the same control panel, you would also find a handouts tab, and that's where you'd be able to download the slide deck for today's webinar. So that's it from me. I'm going to pass on the time to Douglas Raitt, who is the Regional Advisory Services Manager at Lloyd's Register. Douglas, the time is yours.
Thank you very much, Tim. Welcome everybody to this webinar. I'm delighted to be part of this webinar and certainly being joined by some esteemed guests such as Felix and Pieter to discuss the importance of life cycle assessment in the context of, I would suggest, not only methanol as a fuel, but many, many other alternative fuels that might benefit from such methodologies. Felix is the sustainability manager for liquid wind, and Pieter is and it's a handful, is senior consultant, maritime knowledge and project coordinator, Green Maritime Methanol Center. So before I hand you over to Pieter and Felix respectively, I would like to discuss about maritime decarbonization and the challenge that shipping is and will be facing in the short to medium to longer term, because it is a very, very big challenge to the industry. We all kind of have heard about words like chicken and the egg, where to start, where to find the fuel, can the ships burn fuels that are on offer? So it's a very complex landscape to navigate. And the next few slides I wish to Okay. Sorry, everybody, my slides don't seem to be moving. Oh, okay, here we go. So we all know why we are here. We know that IMO has put the challenge to shipping to reduce its carbon intensity by 40% in 2030 and by 70% in 2050. Overall, achieving a 50% GHG reduction against the 2008 baseline. And that's a significant challenge. And in the short term, we all know that the shipping industry is very much busy with making ships more efficient through the application of EEXI, which will come into force at the end of this year. We also know that shipping owners and charterers are looking at the impacts of CII, carbon intensity indicators, in the next few years to come. And of course, we are slowly but surely seeing collaborative industry efforts to start trialing alternative fuels and looking at technology to enable the adoption of alternative fuels. So in the medium term, up to about 2030, we will have to actually see what much more wider industry collaboration, more pilot projects to enable the shipping industry to understand what are the viable and what are realistic alternative fuel strategies to pursue in the 30s and the 50s up to the 50s. Then in the 2030, we really need to see the scaling up of zero carbon fuels, a wide adoption of renewable fuels, the emergence of electro fuels. And then in the 2050s, ultimately, we need to see a sharp decline in fossil fuel bunkers in favor of alternative zero carbon fuels. So these are, in a nutshell, the challenges ahead for the industry. And I believe that the time that we have now until the 2030s is absolutely critical to get going in order for shipping to be able to realize the IMO's ambition of carbon intensity reduction of 70% by 2050. We as LR, we have not stood still. We have published a variety of papers now to enable the industry to gain knowledge and understanding, and also perhaps look at the framework that we as Lloyd's Register have developed to assess the availability and the feasibility of fuel transitions. Some of the publications that we published was Low Carbon Pathways 2050, How Might Shipping Be Required to Change, Zero Emission Vessels 2030, What is the Economic Viability, and a variety of other interesting publications which the industry can freely obtain through the Lloyd's Register website. And as part of our engagement with the industry, we also recently launched a zero carbon fuel monitor. And it's a busy slide, but I'll try to explain it in simplest terms. The way we look at the challenge for the industry is that marine readiness of alternative fuels is very much an interplay between technology readiness, investment readiness, and community readiness. And technology readiness really is about the technology that will enable the combustion of alternative fuels on board ships. In tandem with that, investment readiness is also strongly linked to technology readiness. Are the manufacturers or the engine manufacturers putting investment in to enable the industry to transition to lower and zero carbon fuels? In terms of investment readiness, we can also look at the infrastructure piece. What investment is being made by the infrastructure conglomerates to bring a viable amount of alternative fuels, be it methanol, ammonia, hydrogen, and so forth, to the shipping market and enable the shipping market to adopt those. Then the community piece really centers around, well, what is the policy required to actually enable the adoption of zero lower carbon fuels? Because ultimately, if we look at it at face value, fossil fuels are way more competitive compared to the alternative fuels that we will be talking about, in particular methanol, during this webinar. So there is a need to create a level playing field and allow the industry to actually start moving in a positive direction and start embarking on a fuel transition. And you can think of things like market-based measures where the price of fossil fuels will be somehow penalized in favor of the cleaner fuels. So in order to bring prices in parity and therefore allow shipping companies to move and transition to newer fuels. Life cycle assessments, of course, which is the topic of this webinar, which Felix and Pieter will talk about later, is also a very important aspect. So in summary, marine readiness is an interplay between technology readiness, investment readiness, and community readiness. And our Zero Carbon Fuel Monitor, which you can try out on our Decarbonization Hub website, is basically assessing the variety of fuels that we are looking at now and see, are they technically ready? Are they investment ready? And is the community ready? And we give different ratings of maturity. So for example, with methanol, technology readiness is relatively high and mature, as is the potential fuel supply chain. For ammonia, for example, technology readiness is still somewhat of a challenge, and therefore we at Lloyd's register then look at these kind of variety of ratings and then look at what is the work that needs to be done to move the ammonia, for example, into a more mature technology readiness path. And that could be done by potentially doing a QRA assessment on ammonia to enable to move the dial for such fuel. So ultimately, go to the website, have a play. You can basically choose any fuel you want, and it will give you kind of an assessment from a scale of 1 to 9, how mature or immature any given fuel is based on the technology readiness, investment readiness, and community readiness metrics. Then a way that we look at it is to somehow overcome the chicken and the egg situation when it comes to fuels, is really how do we bridge the gap between demand and supply. So we have a first movers framework developed that literally looks at, okay, we have ships, we have geographies, and we kind of build linkages between the global fleet and fuel supply. And it enables a comparison of different fuel transitions. So a transition strategy can then be kind of mapped out that can also then somehow facilitate fuel production routes and also give an understanding of what the cost drivers are to enable shipping to meet supply or supply to meet shipping. So it's really looking at it from the outside in and basically find a convergence where a safe and sound transition to the new fuels can be enabled. So in very much actually, if you think about it, some of the green corridor projects that we are well known and read about in the media are kind of similar in nature, right? You find partners to work with that will enable you as a shipping company to chart your strategy forwards and enable to achieve and move in tandem and ultimately meet the IMO decarbonization goals. So the key messages as we see it for the industry is the primary driver is fuel price. Yes, we know that the capex of new ships and designs that will enable the adoption of these new fuels will be more expensive and attract a higher capex, but ultimately the total cost of operation of any given fuel will lie in the OPEX of running such fuel. So a carbon price is kind of needed to close the competitiveness gap between fossil fuels and the new fuels. Then when it comes to technology, the zero carbon fuel ships are technology possible in 3 to 5 years. For methanol, arguably already not a problem. For ammonia, within the next 2 to 3 years, certainly will be enabled. Safety challenges can and will be addressed through the application of QRAs, HAZOPs. And finally, the bulk of the technology is actually not within the shipping community. The shipping community has proven time and time and again to be very adaptable to rapid change and regulatory challenges. The idea of a ship running on non-fossil fuel is a relatively simple challenge to address. The challenge is actually in the supply chain and the infrastructure. How do we get those fuels to the end consumers, the shipping companies? And that's a real challenge, which hopefully Felix and Pieter will also shed some light on today. But that's really, I would suggest, the challenge that we need to overcome. And the only way to do that is by partnering with land-based infrastructure companies to enable shipping to get the fuel that they need to feed global trade. And then finally, community, and I've mentioned it in the previous slide. If we look at alternative fuels, we need to make sure that we don't shift the burden of reducing greenhouse gases upstream. So we really need to ensure that there is a robust well-to-wake framework that will allow the true emissions profile from any given fuel to be rationally and fairly assessed against one another. And then finally, of course, market-based measures also play in this community. And ultimately, if we do all of these things well, and we put the pieces of the puzzle together chronologically in good faith and reach the convergence where demand meets supply, I have no doubt that shipping will have the courage and the ability to achieve its obligations for a safer and greener world. So with that, I would like to pass on to Pieter. Maybe Pieter, you can share some of your insights and views on this as well. Thank you.
Thank you, Douglas, for this very comprehensive and concise presentation. I think it put a lot of emphasis on important issues that we're facing, and that I will also address probably in this presentation. My name is Pieter Hart. I work for the Maritime Knowledge Center, and I do that for about 8 years now. And the Maritime Knowledge Center in the Netherlands is a foundation where 4 knowledge institutes work together and address the fundamental issues that are coming our way in the next 3 to 5 years for the maritime industry. So the knowledge institutes like TNO and Marin, but also TU Delft and NLDA, the Dutch Defense University, are connected to this foundation. And there's also like a shell of companies connected around this Maritime Knowledge Center to give feedback on the fundamental issues that we're addressing for the next 5 years, say basically. The Green Maritime Methanol Project is a project that is executed also by the Maritime Knowledge Center. And basically, just to come back a little bit, sorry, to come back on that, the Green Maritime Methanol Project was started in 2017, and basically because in the Netherlands we do have larger ships, but not the very big ships in the ocean-going vessels like container vessels. We have a lot of short sea shipping, a lot of ships also operating near the coast, like dredgers, also inland shipping, of course. And for this kind of shipping, LNG, the first choice of in say the early 2000s, say 2010 and onwards, LNG was not the favorite fuel of choice. So what happened is that we said, okay, we have to look to other alternatives. And of course, in Sweden, they were already, Stena was already doing a project with Stena Germanica. And we said, okay, we should look into that and see if this is a fuel that is also interesting for us as a maritime sector in the Netherlands. So that's we started in 2017 with a small project together with TNO and TU Delft. And we investigated the possibilities of methanol for smaller ships. And the outcomes were very positive, not only for combustion engines, but also for fuel cells. So we decided to move on, and we set up a bigger project, and we contacted basically the Dutch maritime industry and asked them to join into this project, and they did. And I hope my slide will progress. It's not progressing, I think. There it is. So the next step was that we set up a project with about 30 participants, and here you see the logos. It consisted of ship owners, shipyards, marine suppliers, service providers like classification societies, Lloyd's Register, for instance, but also Bureau Veritas were involved, but also methanol producers that are very important, of course, because they are the ones who are providing fuel, Methanol Institute itself, but also port owners and, of course, several knowledge institutes. So we started this project in 2019, and we said, okay, what we would like to do is to see if we can make methanol a viable fuel for the Dutch maritime industry. And by doing so, we moved on, and I think it was a very successful project because there was a lot of input. I think it's also because we were in an early stage, so there was a lot of knowledge to be gained by different parties, and there was a lot of sharing of knowledge also going on. For instance, the classification societies shared a lot about their knowledge on regulations, but also the ship owners on their needs for and their requirements for good fuels. But also, of course, the methanol providers that shared the constraints that were there for methanol and the opportunities that were there as well. So it was a very interesting story. I'll share at the end of my presentation. I'll share some of the publications that we also produced. But this is the starting of a project that was for 2 years, started in 2019, continued up to 2021, and then basically every party was on there said, well, we would like to continue. So we started a second project, and it's called GMN 2.0. And I hope the slides will move on now. And there's some delay, I think. But there were some new entrants, and that's interesting because it was also entrants from abroad, companies like ABS, but also Maersk, Caterpillar from the United States, but also San Lorenzo, for instance, a super yacht builder in Italy that joined us, Victrol from Belgium. So what we see is that we are growing into a more European or even international consortium of companies that are really interested in investigating the use of methanol in the maritime sector. For the objectives of our project, I'll show the next slide. We study the benefits and the feasibility of green methanol for the maritime sector. And well, although the technical developments are considered maybe a problem that we can solve, there's still a lot to be done. There's a lot of engine manufacturers that have to choose the right technology, the right way of igniting the fuel. There's also a lot of things that need to be solved. And although we are positive about it, there is certainly some research that need to be put in there as well. But also, of course, on the logistics, like Doug already shared, and also the operational aspects on the sailing with methanol for the crews on board. Well, what we said for the first project, that we wanted to have system design for several prototypes for methanol, and we did 6 prototypes, and I'll show them later, and for the shipping fuel as methanol. And of course, we would like to work towards actual implementations pilots. That's one of the key requirements, basically also asked by classification societies. In order to make it work in practice, we need not only make designs, and it's the first step, but these designs need to be also brought in the European arena for legislation, etc. And usually what we see is legislation is never early, so we have to start that as soon as possible. And then I like to move on to the next slide. So I would like to put methanol, and that's what we did as well, as a green maritime fuel in perspective as well. If you start a project like this and you have like the big views and you look all over the place, and you see in the distance, you see a little vague. And the closer you come to the details, you see that also in the forefront, you see also the grass in detail, but far away you don't see the grass. So what you see is the more you study things, the more detailed the insights become as well. So what we see is that that we have a clearer picture about methanol, a more detailed picture, a sharper picture, and it helps us to move on as well with the requirements that we have to set upon using methanol as a green fuel. And that's what I like to put it also in perspective with regards to the requirements. Yeah, that's good. It's good. With the requirements on CO2 emission reduction. And this is a very interesting graph. It's made in 2017 already, and it's used a lot. It shows you the CO2 emission reduction potential in shipping. And you see the yellowish brown is the hull design measures that you can take. The green ones are the measures that you can take for power and propulsion systems. The red ones are for alternative fuels. The purple ones for alternative energy sources, and the blue ones on the operation. Well, what you see, because we do not go over all of them in detail, but what you see, if there's 3 issues that can bring a large emission reduction in shipping, and that's vessel size. The bigger the size, the more optimal your transportation chain will be. It's speed optimization, because speed is really costing you a lot as an operator. And it is the last one is biofuels. So if you want to achieve more than 50% CO2 reduction, like Doug said, what the ambition is of the IMO, at least 50, but it's already 70, and it might be even more in the future. Then we need to look at biofuels, and that is the reason why we started that in that direction. Can I have the next slide, please? If we look at the oil consumption worldwide, and this is from a website, Statistica, and that is the oil consumption is about 400 million tons per year, and that's has grown. And of course, 2020 is a little less because of COVID, but say 4,000 million tons per year. If you look at the distribution of the oil demand over the different sectors on the next slide, then we see that maritime, marine bunkers, but also domestic waterways make up about 5% of this fuel. So the 5% of the 400,000 of 4,000 is about 200,000 tons that are needed in oil for the maritime sector. And of course, the energy efficiency of oil is diesel oil is rather high if you compare it to methanol. It's about twice as much energy density compared to methanol. So a lot of methanol is needed in the future if you want to go for the 4,000 and then the 5%, so let's say the 200,000, the 200,000 million tons. If we go to the next slide, we see another slide is also a little dated by Wang in 2013, but it gives you a good insight in the different projections at that time for the fuels. And then we see 2015, of course, there was the SECAs and the NECAs. Was decided upon how to implement that. 2020, of course, then the new regulation on the HFO, and now we're in 2022, and we see that the marine fuels consume about say about 300 million tons, but it also includes LNG and other fuels as well. So a lot of fuel is needed for the maritime sector. And then, of course, how quickly will the transition go towards methanol? If we look at the next slide, then we see again, we see the fossil fuels, the red ones. They show you about that's about 300 million tons, and we see the green ones, and there's many that are available, and we need to choose. Well, some people think we should choose, but I think we do not have to choose too quickly, because we need a lot of fuel. We need, like I said, twice as much as the fossil fuel offers. So say about 400 million tons grossly, and then we come up with ammonia as a good candidate, but also bioethanol, LNG, but also methanol. And so we said, well, these are the ones that are interesting. Of course, straight vegetable oil is also interesting, but I marked bioethanol and SVO and PPO orange because there's a competition with food in this issue. So these fuels also have their backdrops, like every fuel has the backdrops, but I think this is really an issue that is addressed, and at the moment is I think it's not so easy to use bioethanol or plant oil for fuel. So, but it gives you an overview of the fuel that is available. Then we go to the next slide, because what we did in our report, we looked at the methanol production routes. And we said, okay, at the moment, fossil methanol is made from coal and natural gas, but we should also look into the possibilities of using biomass. And it could be black liquor, for instance, but it could be also other biomass that is available, and make syngas out of it. We can use biomethanol or biomass for biomethanol, but also to make syngas, we can also do carbon recycle methanol using, for instance, municipal solid waste. And well, we started with the idea in mind, basically, that it would take up to 2030 to really develop the biomass and the biomethanol route up until 2030, and then we would be able to shift towards e-methanol using, for instance, hydrogen and CO2 from exhaust gas or from air. But of course, Liquid Wind is here today, and they will share about their ideas and their plans and the things that they're going to do. So we see also that there's a speeding up of the process, and I think that's a very good thing to see. I'd like to move on to the greenhouse gas emissions of the different fuel chains, and we do that in the CO2 equivalence in grams per megajoule, and then we take a 100-year global warming potential in this case. So if we compare then the different fuels, we see, of course, on the bottom HFO and MGO, the fuels that are most used, but also biodiesel is a drop-in fuel that is already used in the marine industry a lot today. Well, they are performing well, basically the same as fossil methanol, but fossil methanol has also already the advantage of a low NOx and a low particulate matter, and of course, well, a low or almost zero SOx. So for the not so much the greenhouse gases, but all the other emissions, fossil methanol is already a solution. But we look here particularly at the greenhouse gas emissions, and then fossil methanol will not be an improvement. But if we look to biomethanol or we look to e-methanol, then we see a considerable improvement. And what you see on the bottom, the dark blue is the well-to-tank, and the light blue is the well-to-tank range, basically. So where we think it will move depending on the feedstock, for instance. So then we see a very good figures for e-methanol and biomethanol, and especially when you compare it, for instance, with a fuel like LNG. We see that bio-LNG is not doing as good as biomethanol or e-methanol is doing. Then I'd like to move on to the next slide. So we still believe that biomethanol is essential, especially with regard to availability and price, because at the moment not a lot of biomethanol is produced, and the price is also has to compete with for instance, well, at the moment with diesel or with biodiesel, and so it's really important for ship owners to have a competitive price. It might not be for all ship owners, because there are ship owners that where it will be a license to operate, but for the ship owners that need to compete with other ship owners that are still using HFO or NGO, they really need also a price that is affordable, and it will not be the same price as NGO or HFO maybe, but at least the price needs to be in a competitive range. What we see is also here in the Netherlands is a thing that bothers me a little bit, and I just think it's also good to share that here. In the Netherlands, there's a priority for electrification and green hydrogen, and then they say, well, especially for personal energy in the service sector, it's for energy for industry, it's for oil products and chemical feedstock, and then and the last point in the agenda is for freight transport. So what we see is in the Netherlands, electrification and green hydrogen are priority, but freight transport is not a priority. And we try, as in the Netherlands also, we try to move that up to the ladder, because we think it's also important to do that, and that we will not lag behind. Well, then we of course see the pricing. Well, what we studied in the Green Maritime Methanol Project, and we see that, well, we projected e-methanol as 68 euros per gigajoule, but I understand that liquid wind is doing much better. So that makes us happy, and makes us also curious how we can move on. And maybe we should can skip this step, but I think we need to really ramp up the production of methanol. Well, the next slide shows you the 6 case studies that we did in the first project, and there was a big dredging vessel. It was a naval vessel, an auxiliary vessel for the Navy. It was a port vessel for the Port of Amsterdam on the right. There's also a patrol vessel for the Ministry of Infrastructure in the Netherlands. And what we see is that both the Ministry of Defense and also the Ministry of Infrastructure, in the Netherlands, they are very keen on using methanol as a fuel for the new ships. So there's fleet renewal programs going on, and we really see that there's a lot of interest, and yeah, we really hope that we can make live pilots there as well. To move on, we go to the vessel Van Oort. It's a cable laying vessel, and the last one is a ship from Wagenborg. It's a general cargo vessel. So these ships were evaluated, and the interesting thing is that it was not always easy to have methanol on board, because on existing ships, methanol has a different energy content, like we already said. So you need more bunkers, you need different safety requirements, but also the bunkering process is a little different. So safety areas are very important, and then we come and talk with Lloyd, of course, and with the BV about how to make these safety areas safe, especially with work vessels where people work on deck. So these were really interesting issues that we studied, but we see there was a lot of enthusiasm to share information and also to move on. Then I come to one of my last slides, and I will not go into all the details. So I would like to state to the recommendation that we made, and I think it's maybe one of the most important recommendations that are made in the report, that there is still uncertainty concerning availability and pricing of sustainable methanol, and because policies and legislation are very important in the steps towards implementations, result will be discussed with policymakers, and that needs to be done in a national but also European and international level. So this concludes my presentation. I have one slide still, Tim, And that is the reports. Just like Lloyd's Register, we made all the reports available for everybody to look at. And there is on the bottom, you see the work package 6, the final report. So if you don't have time to read all the reports, you can take the last one and have a concise summary. But you see the link on the slide as well. There you can download the reports if you want to. So thank you for your attention. And I would like to give the word, and I think, to Felix.
Let me see if I can move the slide. That was too fast. Thank you, Pieter, and thank you, Douglas, for the introduction, and the Methanol Institute for hosting us. My name is Felix Jung. I'm Sustainability Manager for Liquid Wind, and I'll be presenting a bit our views on well-to-wake approach. We recently published a white paper on the life cycle analysis of e-methanol. But first, I want to introduce what Liquid Wind is. We are a project development company that's focused on e-methanol facilities. We're currently in the closing stages towards financial close for our first facility called Flagship 1, where we produce around 50,000 tons of e-methanol while upcycling 70,000 tons of CO2. And that facility will be in the north of Sweden, and hopefully we're planning to produce our first quantities in 2024 and start construction later this year. We have a pretty steep scale-up plans. We're aiming to have 10+ facilities by 2030. This means either 10 Flagship 1 size facilities, but we're aiming towards bigger ones to have the ability to produce more e-methanol and more at scale. Just a quick overview what the production pathway is for e-methanol. In essence, it's the combination of green hydrogen and CO2. At Liquid Wind, we're producing the green hydrogen with electrolyzers based on renewable energy, specifically additional wind energy. That means the wind farms are going to be constructed during the same time frame as our methanol facility. And then at Liquid Wind, we focus on using biogenic carbon dioxide, which is very important to us, as we believe this shows the true circularity in the fuel. And these sources can be pulp and paper mills, biomass CHPs, for example. And then this is combined in a reactor to produce methanol, which then can be used in the maritime sector, as we heard today, but there are also different applications. We're a relatively small development company. That's why we have collected a strong consortium of different international players. Worth to mention that Ørsted recently already purchased 45% in our first facility and has the option to purchase more at financial close. And to our right, there's Energy, which is the biomass CHP for our first facility in the north of Sweden and Örnsköldsvik. Just to illustrate what that looks like in the e-methanol plant, this is a render of our facility. On the left side, we can see the already existing biomass CHP that currently produces district heating and electricity from waste forest residues, so wood. And we basically dock onto their flue gas stack to then capture the CO2 and combine it with hydrogen in our facility. Now to the main topic of today's webinar is the well-to-wake, and as Tim mentioned also earlier, that this offers more transparency. If you look at the diagram on the right, we can see that currently the shipping industry is focusing on tank-to-wake emissions, so propulsion energy. And if we expand that scope to well-to-wake, that means capturing the whole process of producing those fuels. That's basically the upstream process which is usually referred to as a well-to-tank. At Liquid, we conducted an internal life cycle analysis. Just as an overview, a life cycle analysis, the purpose is usually to determine environmental impacts. It helps to compare products of same function. You can evaluate processes and compare them, and finally use that knowledge also to improve products or services, for example, also in the shipping sector. For our internal lifecycle analysis, quickly on the methodology, it's pretty clearly defined by ISO, but it can be interpreted a bit differently. That's why we're still waiting for standardized methodologies for marine fuels. But generally speaking, you start with a goal and scope definition. That means you start to think, what do I want to investigate? In this case, it would probably be what are my emissions per megajoule fuel, and how does it compare to other fuels? We also looked at what is the environmental impact of the liquid product, so meaning the methanol before it's combusted, so when it leaves basically the gate of liquid. The next step is an inventory analysis, so you look at what are the material energy flows in that process. And in the third step, you do the impact assessment and you look what are the environmental impacts of those inventory, And then in the interpretation phase, you use that data gathered to make sense of it, to have comparison, and then to act on it. A bit more specific on the inventory analysis at Liquid, we used a material energy flow analysis, which is basically putting the complex facility into manageable chunks. So basically split it in different modules. So for example, electrolyzer, and we have a carbon capture part, the methanol synthesis part, and then we conduct an input-output analysis for each of these modules. But I'll get a bit deeper into that in a moment. So this is what it looks like. So everything inside the bigger box is in the scope of Flagship 1 until the dotted line. So this is a Flagship 1 facility, what is part of what we looked at in our input-output analysis. Then we have inputs that are a bit outside of the scope, like electricity. And then we have outputs like flue gases, off gases, water that's not used. And then, this is the Flagship 1 facility, where we then have the product methanol, and where we have then a functional unit, which means emissions per kilogram methanol, as it's a chemical that's comparable with other kinds of methanol. Then if we go further and expand the scope, we have the transport of the methanol and the usage on board combustion, where we then use the functional unit, as Pieter T also said earlier, gram CO2 equivalent per megajoule, to compare fuels of different chemical. Just to quickly explain how an input-output analysis can look like. For us, we always look first at the material flows in each module. So you look what's actually happening. For an electrolyzer, this would be we have water as an input, and then it's converted into hydrogen, which will go into the compressor, and to oxygen, which is either released to the atmosphere or can be used in other industries. If there is an off-taker. Then in a second step, you look at the direct flows, what is needed and what is actually emitted into the atmosphere. In this case, the electrolyzer runs on electricity, and we have an emission of oxygen to the atmosphere. In the third step, this can be seen as the scope 3 emissions. So what are the emissions of the electricity upstream, so in the production? And for example, what is needed to produce that demineralized water, because it's processed water. And these are basically then volumes. And then we have a database. These are scientifically based databases or actual data that you can connect to these volumes, and then they come, for example, with the CO2 equivalent per specific unit. So if you then multiply this with the volumes you have, you get a carbon footprint of each module, and then you can add them all together, and then you get a carbon footprint of your final product. Before I come to the results of our internal life cycle analysis, just a few main assumptions, because that's quite important to make them comparable. Our process is based 100% on wind, and we use the carbon intensity of 6.5 grams CO2 equivalent per kilowatt hour. That's a bit different to some of the methodologies. Some use 0 if it's on renewable energy, but for us, we want to be completely transparent. That's why we used even an emission for using renewable electricity. In our methodology, we use a negative carbon credit for capturing CO2, meaning we'll start off with negative emissions, but then we account fully for onboard combustion emissions. This is usually done a bit different for biofuels, for example, because there the carbon capturing inside of the plants is outside the scope. That's why they treat biogenic CO2 emissions on board often as 0. And we are ignoring in our LCA the embodied emissions of technology. That means emissions produced during the production of, let's say, the electrolyzer itself, because these are in fuel production usually negligible. If there's good data, that can be added as well, but often if you have uncertain data and it doesn't add any value to the final result, it's usually not beneficial. So to the result, well to tank, basically what is the liquid methanol product before it leaves our gates. Yeah, you can see in the graph we have left the credit for CO2. So per kilogram methanol, we capture about 1.4 kilogram of CO2. Then we have some emissions during the methanol production, and that leaves a net emission of about negative 1.3 kilogram per kilogram methanol. That basically means before the combustion, it's a carbon sink. So this is also interesting for other industries, for example, in the chemical. If you produce a product, for example, that it's not combusted right away, you could argue you have a carbon negative product. If we then expand the scope to have to the maritime sector, so the well to wake emission, again we have a bit of a waterfall diagram here. So we start off with the carbon capturing of the carbon. Now our functional units gram CO2 equivalent per megajoule. We have the methanol production, which has some emissions. In our process, we do have some recovery of emissions because we feed excess heat into district heating network, which can be added as a credit because we're replacing other production. Then now we're also including the methanol transport and then the onboard combustion, which brings it back to a slightly net positive emissions of about 5 grams CO2 equivalent per megajoule in our case. And this is again using electricity at 6.5 grams CO2 equivalent per kilowatt hour. If we use a methodology where you don't have emissions on renewable electricity, this would be even lower. There's a small comparison what we see compared to fossil fuels with a 5 grams CO2 equivalent per megajoule. We see around a 94% CO2 reduction compared to marine gas oil, LNG, and also fossil methanol. And we see, generally speaking, an outperformance of biomethanol. But as Pieter already said, this is individually, has to be investigated because it depends, significantly on the feedstock for biomethanol. Just to illustrate the importance also of the electricity source when producing e-methanol is we did a small sensitivity analysis. How would our carbon footprint look like depending on different electricity sources? We can see, so the red line is basically the fossil marine fuel threshold, and then we are here with our Fletcher 1 facility with a carbon intensity of electricity supply of 6.5 grams CO2 equivalent. If we go down to 0, we are close to 0. It's too small on this graph to show. But for example, if we were to use electricity from the average grid in the EU, we would end up about more than three times of life cycle emissions than, for example, marine fuels. Therefore, the electricity source is the main driver for the sustainability of these marine fuels or e-fuels, especially. Something I wanted to present as well. There's also a publication by the Sustainable Shipping Initiative. They show criteria on how to assess marine fuels, and this is also a good approach when using a life cycle analysis. It opens the transparency upstream and basically enables a scoring almost on SDG criteria, so sustainable development criteria. So if companies can basically say, I want to focus on these specific criteria, you can basically score different fuels based on those and use those also in your, let's say, sustainability reporting. So it doesn't necessarily only have to be used for greenhouse gas emissions. Finally, some summary why we think well-to-wake is the right approach for the maritime sector. It avoids burden shifting. You can't shift emissions somewhere upstream or outside of your boundary. With a transparency, and having the LCA approach, you have reputational risk protection. That means if you ensure that your fuel comes from good upstream sources, this avoids greenwashing attempts or allegations. It also enables accurate comparison and benchmarking between different fuels, and thereby also accurate emission accounts and levies based on actual emission and environmental impacts of the fuels that are used on board. And finally, since there can be a premium on lower footprints, it's also incentivizing sustainability innovation along the supply chain, meaning if the off-taker of the fuel interested in low carbon footprint, this also pressures upstream production and incentivizes efficiency along the supply chain. That's from my side. Thank you for listening. I'm happy. You're welcome to check out our white paper and let me know if you have more questions.
Thanks very much, Felix, and thanks very much, Pieter. I have a question before we go to some of the questions of the webinar attendees. I'm looking at the piece of work that you've done for liquid wind, Felix, and bearing in mind that at IMO level and also at Fuel EU Maritime, there are similar initiatives on the go. In how far did you lean on that work, or if you didn't, what do you believe are the similarities between that work being undertaken at regulatory statutory level and the work that you've done for liquid wind, Felix?
Yeah, absolutely. So the work we've done, I would say we started it before it was actually going at the IMO level. But now looking at the outcomes, and especially also with the Fuel EU Maritime, I definitely see similarities. We are splitting up the emissions basically from well to tank and then tank to wake, which is done in Fuel EU Maritime. And I think that's a good approach because then you can basically use default values tank to wake, and then you have supplier information, for example, that you can use well to tank. So I think it enables to capture the use of e-methanol because you have the carbon capturing in your scope, and you kind of treat methanol as a product that's then combusted, then just
Pieter, you have any thoughts yourself here?
Well, I think it's very good that at the moment we talk about well to wake, because I think within IMO a long time it was a tank to wake, The discussion was, for a lot of people, was not even clear what we were talking about. So I think by studying these issues and making it also clear to the public and to other regulators what we are talking about and what we are doing, and to make that clear in a concise way is very important. I think the different studies from whether it's Methanol Institute or a Liquid Wind or Lloyd's Register or TNO MKC, they all contributed to the same issue, is to make it clear and to let people think about what are we talking about if we move into the future, because we cannot keep it only with tank to wake. That will be a discussion where we find each other maybe 5 or 10 years from now down the road in an alleyway where we would never wanted to start in the first place.
Very good perspective, Pieter. Felix, I want to kind of get back to that point you just made, right? The well-to-tank life cycle assessment. That's all good and well that from a supply side, you could potentially certify the emissions impact for, let's say, electrofuels, right? But how does the supply chain itself regulate that when a ship owner buys it, and we go from tank to propeller discussion, that they actually bought an electrofuel, right? Because at the end of the day, methanol is methanol, right? So how does one know if one actually received an electrofuel methanol or a gray methanol for that matter? So there is a security risk in all of this from a practical implementation perspective. Any thoughts on that, Felix?
Definitely, that's a big point, and I think you're driving it, for example, double counting as well. So I think there will always be a place for a certification agency, for example, or a central registry is probably needed to really ensure that every e-methanol produced is then, for every metric ton produced, is used only once and not sold several times. I think there are different also tracking possibilities potentially. I think it's I think there needs to be transparency, and I think in the electricity part, for example, there are guarantees of origin. We have book and claim systems, which could be a possibility. But so far, I think we're still with using mass balance basically when we provide fuel around the world.
So with that in mind, right? Excuse me. With that in mind, what are the challenges for ship owners that want to evaluate alternative fuels now? And how can they handle this? And how will a standardized methodology solve this in due course? Because what you've proposed now, yes, is a sensible, perhaps sensible way of looking at it, but it's not a reality of how to evaluate it just now. So what does the poor or the challenged ship owner need to do to get a handle on what their fuel transition strategy ought to be or could be?
Yeah, definitely. I think it's a good question, because the essence, or what LCA needs most is the accurate data, and that's usually missing for the ship owners when they want to conduct the life cycle analysis themselves, because at the moment, since there's no methodology, ship owners kind of have to lie down their own methodology, or at least their own assumptions that work for them, and then you can actually compare different fuels, because it's only comparable if you base it on the same assumptions. So ship owners here have to do their own homework in a way, assess marine fuels, but that obviously needs the data from suppliers, for example, or at least they need to be transparent on what methodologies they use and how they conduct it. Because even in the scientific space, I see it's pretty rare that they're consistent papers that evaluate marine fuels. So it's definitely not easy for a ship owner to get a grasp on actual data. But right now they will have to do it themselves and lie on their own methodology. I think when we have standardized methodology from the EU, the IMO, then you can actually rely on also the data that they, or the carbon intensity they provide to you, and you can compare it. And ideally then also certified by certifiers, for example, that then also can use a standardized methodology to make sure that different certifiers still use the same tools to evaluate those fuels.
Interesting, Felix. One thing that didn't escape me, you talked about the global or the CO2 equivalent values, and we know that we can assess CO2 equivalent values on global warming potential timeframes, which typically could be 20 or 100 years, and Pieter mentioned it as well. So I would like to have your take both on it. What GWP should be used to get a fair assessment on marine fuels? And on that matter, Felix, what GWP did you actually use in your LCA study?
Okay, maybe I can start. Yeah, for my study, I used the GWP, or global warming potential, of 100. To quickly explain me what it actually means, basically the global warming potential basically explains how much energy is absorbed from the emission over this time frame. And usually the norm it towards CO2. That's why it's called CO2 equivalent. So if we look at e-methanol production, we mostly have CO2 emissions. So it's one. So the norm is basically 1 per 1 gram. Anyways, if it's 20 years or 100 years, so there's not an impact in that way. But if you then want to evaluate, for example, methane emissions, fuels with a lot of methane, then that are a little bit more short-lived, so they have a shorter life cycle. And so if you use a global warming potential of 20, I think it's around 80 to 90 times of CO2, and the global warming potential of 100, I think it's around 30 times. And with knowing how fast we need the energy transition, definitely evaluating fuels and compare also more fuels that emit methane, it makes sense to have a global warming potential of 20. Because yeah, I'm thinking of, for example, tipping points in the climate crisis, right? So we have to be fast.
Pieter, any of your thoughts on this?
We used the 100, the 100 years. So, and I think it was because this was the one. Well, we are talking about 2015 and beyond, and of course everybody's talking about the importance of starting now for something that we might need in 70, 80 years from now. So that's the reason why we chose hundreds. But I also agree with Felix that for some fuels, 20 might be a better figure to use, especially with regard to LNG. On the issue that you addressed before that, Douglas, I think it's the fuel issue and the clarity of where does the fuel come from, the LCA discussion, is also for all fuels, of course. And I think we here in the Netherlands, we already have had some examples with the use of HVO that is also diesel, but biodiesel, and you can at least distinguish what is biodiesel, what's not biodiesel. But still, there is a real need for clarity there, because it is easy to fraud, basically, and we've seen that already, and we don't want that in our industry.
Yeah, exactly. I mean, as you say, HVO, the final product, looks like MGO, right? So how does one know whether or not it was from hydrogenated vegetable oil treatment or it was a fossil-based MGO, right? So we really need clarity so that people buy what it says is on the tin in order to achieve, of course, the reductions that they seek in overall CO2 equivalent emissions. Just pulling the discussion a little bit back from the detail of LCA, what policy measures do you feel will accelerate the adoption of new fuels? And don't think methanol, just think now of just the entire decarbonization journey, because currently we're still kind of at the chicken and an egg situation. How can we accelerate? I mean, what are your views on it, Pieter?
Well, I think at the moment what we see, there's two things. So we can use premiums if you use a biofuel, or you give a penalty if you use a fossil fuel. So that's basically what I think are the two brands that are there, or the two tastes, or whatever you call it. But I think at the moment what is happening in Europe is a good development, because I also think we should share the load, not only on one company or one sector, but all sectors should do so. So I think the initiative taken for the Fuel EU Maritime and the Fit for 55, I think is very positive, but it is still on the move. So we are very curious what will come from this. So where does it end, and what does it result into? Because it is really important at the moment for ship owners. Like I said, if you really have to make the business case, and you sail with containers or general cargo over the ocean, and you want to do that with methanol, green methanol, or any other green fuel, then you really have to compete with other parties that are still using MGO or maybe even HFO. And that's a challenge, because you can do that maybe for a week or for a month, but not for much longer, because then you will lose. So I think what's happening with the EU, I think it's a good initiative. I think it's a very good approach. I think if we take well to take into consideration consistently, I think it gives me a positive feeling. Let's put it this way. So I'm hopeful what is happening there, and I hope we can do it also in an international level. Although I think that would be more complicated, because IMO is not only about the European countries, but it's also countries that might not want to move so quickly into advanced fuels.
Yeah, I mean, Pieter, to an extent, these are all valid points, right? But there is something to be said to have a multilateral approach rather than a unilateral approach, because of all geographies are coming up with their own regulations. To an extent, it will become a patchwork, which will be quite a challenge for the maritime industry, I would suggest. And also, and thinking of my bunkering experience in the past, if, let's say, EU goes it alone, the premiums of fuel might rise, and bunkering might actually get favored in other areas which are maybe not as mature as the EU and their thinking, because their global their regional bunker prices will be more expensive than other areas. So you might see that fuel will be diverted out of EU into other regions, because ship owners can get bunkers cheaper than in the EU. So that could be an unintended consequence, I suppose. But Felix, what's your take on how we can accelerate the adoption of new fuels, and what do we need to do as an industry or at policy level to make it happen?
Definitely, I think the main issue is still the price gap between green fuel and fossil fuel. As Pieter said, you're still competing for the same services in the end. So there needs to be measures that bring them closer. We have the inclusion of the EU ETS scheme, for example, in Europe. That will do a bit, probably not enough. So there's definitely at least either more help needed, or let's say more ambition needed in the regulation really pick up, because right now I guess it's the time for first movers, and there's definitely support needed to kickstart this whole development. I mean, I think Flagship 1, our liquid wind facility, will be one of the first industrial-sized facilities, and certainly there will these volumes, even though the 50,000 tons are quite one of the first or the biggest up to date, but in the end it's a drop in the ocean, figuratively speaking. And then, but we need those projects to actually show that there's maturity, that it's possible, and then you also get the availability later on.
Yeah, these are all good thoughts, and I would suggest, yeah, I'm certainly broadly aligned with those. Other than perhaps a unilateral approach on different regulations, a more multilateral approach, I think, would be preferable for the maritime industry. But one thing that has intrigued me, right? If you look at bunker fuel as is, it is a product that is bespoke to the maritime sector. There's not that much competition for that product, right? But when we look at methanol, for example, let's face it, methanol is made for other purposes and not for marine. So how are we going to overcome the challenge that methanol is not a bespoke fuel for shipping? So there's competition for the same product for land-based applications. How do we overcome that? And to be fair, that applies to other alternative fuels as well. But I think methanol in particular, you look at the global production capacity, Tim, let's say 110 million tons a year. And I'm like, shipping needs maybe, let's say 200 million tons, assuming that 1/3 or 1/5 of the global fleet will turn into methanol. Let's say, call that a scenario. How do we overcome that competition for the same product? And what do we need to do to collaborate with land-based infrastructure in order to maintain pace for potentially an accelerating methanol demand for shipping?
Well, Douglas, I fully agree with you. This is an issue that I also addressed in my presentation, but I'm also positive because what I remember that 2 years ago I was invited, I think also by Methanol Institute, to go to Copenhagen to an event there at Maersk. And I know Maersk shared a story there. They say, well, we are going to study the use of alternative fuels up until 2030. And then we are going to decide what kind of fuels we will use in our ships. That was 2 years ago. And so I was very happy to hear from Maersk that they were investing not only in one vessel, but in several vessels at the moment to use methanol. That's one thing. The other thing is, well, what I talked to a colleague of Felix at the Liquid Wind, and I got into contact with him, and I also met one of his colleagues also in Copenhagen, and they shared their vision on using hydrogen and making hydrogen from liquid wind, and doing that and making also methanol as a ship fuel. And well, at the moment they have progressed also quite a bit, and they, well, as a smaller company, they seem to progress very rapidly, and they even have big investors on board. So I think that's a positive thing that I really think we should try to build on and move on. And of course, not all the methanol should be available now right away, but it's really an issue to address. So I'm positive, but I also share your your worry maybe if this will happen. And of course, these things I hope we can stimulate the sector to move on and to really ramp up, because there's no fuel, whether it's methanol or it's ammonia or ethanol, they have their own already, their clients already. So everything needs to be ramped up. It's everything needs to be more than there is already. So that's really going to be a challenge. And I think, well, here in Europe, maybe to finalize, we use electric cars, and people say, well, of course we use methanol and also ethanol to mix in with gasoline, and with and if we reduce that amount, we might have more methanol and ethanol available also for the shipping industry. So that might help us in the beginning to step up a little bit with biofuels. So I think these initiatives are, in my opinion, positive signs, but they will not fulfill the whole demand as you addressed.
Yeah, and of course, you mentioned earlier as well, energy density, right? You need twice the same amount of methanol to get the same bang for your buck as using low sulfur fuel oil or gas oil for that matter. So the scale of upscaling the methanol production to potentially keep pace with methanol as a fuel consideration for shipping is not for the faint of heart. Felix, you have any thoughts on this as well?
I think, as we said earlier on, I think it's quite important that there's a cooperation between suppliers and also the demand on the maritime side. So you can go into a bit more of a cooperative way and then just having a supplier-customer relationship almost. And I think there are ways to at least secure volumes for the future. But yeah, in the end, I think if it's an open market, the e-methanol or biomethanol will go where there's willingness to pay. So I think there's also a need to educate customers on sustainable fuels to make sure that also the shipping customers are happy to pay a premium for goods delivered or transported on green fuels in general. So I think this is quite important.
Okay. I'm just seeing a question from the audience, and it's perhaps a very specific question, but I'll take the risk of asking it anyway. What impact will the various future fuels have on ship design and construction? And perhaps, Pieter, you're probably more versed in answering that than Felix, but so I'll chance my my question with you.
Well, what we see is there is definitely an impact on ship design. So we talked about energy density, and diesel has been a very favorable fuel for the last 100 years. So we need to change our designs. And the designs in shipping were optimized over the last 100 years for diesel. There will be new designs. There will be a lot of innovations, I think, because now we are starting in new areas and new directions, whether it's methanol or the alcohol fuels or ethanol, or it might be ammonia, it might be hydrogen. What we see at the moment, there is such a wide variety of fuels being offered, of systems. We talk about combustion system. What kind of combustion? Is it compression ignited? Is it spark ignited? We talk about fuel cells. Is it the PEM fuel cells? Is it SOFCs? So it seems like an explosion for the maritime industry. What route to take? And I think it's important that we together make good decisions on these fuels, on the way we are going to use them. But and then in the later stage start to standardize as well, and that's of course where Lloyd's comes in, and other classification societies, and also the flag states. What are the safe options, and how do we do that? But I think at the moment we're in a well, basically I think we call it the green fields of so many options and so many things that we try to combine, and maybe the next 5 years a lot of things will develop. So I think there's a lot of uncertainty, but there's also a lot of opportunity, I think, at the moment.
Yeah, I mean, I fully agree with you, Pieter. I think another consideration to make, of course, with energy density, there's two things you can do, right? You can increase the size capacity of your bunker tanks, or you go for more frequent bunkering, right? And then you come into that specialized techno-economic analysis. What is the impact of more frequent bunkerings and smaller tanks? Or what is the impact of lesser frequent bunkering and bigger tank capacity for the new fuel? So it's going to be a very interesting next few years. And recognizing that we're almost at the end of the webinar, just a final question to both of you. How do you see the next 10 years play out? And Felix, maybe you can start here.
Well, hopefully, I think we'll see a ramp up of alternative fuels, especially methanol being adopted. We'll see the first vessels running on e-methanol, which is quite exciting, and will prove that it's doable, and it's also economically feasible, because I think there's a willingness to pay for this premium to transport carbon neutral in a way. So I think it's quite exciting to see the maritime sector shifting to these alternative fuels.
Pieter, last word from you.
Yeah, I also hope that methanol will be an important fuel of choice. I don't think there will be one fuel, but to me, if we compare it with ammonia, LNG, and hydrogen, that are also candidates, and also batteries, of course, I think methanol will do very well in the mid-range of the shipping, and that's a huge part of the ships. So I think for the European arena, it will be an important fuel, and I really hope that we can keep up with the demand that's going to come and get a good pricing, so that we really can make this transition over the next 5 to 10 years.
Excellent, Pieter. Yeah, I would concur with that statement, especially when you say multi-fuel future. There is no winner in this race, right? All horses are in the race, and all of them will have favorite people, considering them as a sustainable and solid bet for their decarbonization transition strategy. So I would fully concur with that. It's not methanol as the fuel of the future or LNG. It's a view of all of them have an important role to play, and all of them will be, depending on what ship operator you are, what ship type you have, what trade routes you are operating at, will give you an indication of what your potential fuel or chosen fuel for the fuel transition strategy should be. And on that note, we have come to the end of this webinar. I'd like to thank all the webinar listeners and people who contributed to the questions very much. I hope everybody found it interesting. From my perspective, and for me, last words are, I have no doubt collectively as an industry, we can pull through this challenge and deliver a greener and cleaner future for the next generation by basically collaborating together. So all stakeholders across the entire supply chain, I have no doubt will make it happen. So with that, I thank everybody and wish you all a very pleasant remainder of the day. Thank you.